This is filament, and this, the material it's made out of, plastic pellets. But did you know you can actually save a lot of money by 3D printing directly with them? Look, while this spool of nylon carbon fiber costs $50, the same amount in pellets is only $5. And you have similar savings with PLA, PETG, ABS and other 3D printing materials. But why is there such a price difference even though it's the same material? I'll answer that in a minute. Because the important thing to understand first is that 3D printing with pellets, which by the way can be done on most desktop 3D printers, probably even yours, has many advantages that filament simply doesn't have. That's why we will compare today filament and pellet 3D printing within 7 different aspects to find out which of them is actually better and whether you can 3D print with pellets on your own 3D printer or not, and maybe even with chocolate, but more on that later. So let's go and let us start with the price comparison first. Usually most common 3D printing filaments cost around $20 to $60 per kilogram. However, with plastic pellets, the cost for literally the same material is on average 5 to 10 times less. For instance, what is the most popular plastic used in 3D printing? It's PLA. And while a high quality filament spool from that material costs on average $25, PLA pellets cost only $5 per kilogram. But why is this so? First of all, you need to know that most plastic you encounter in your life, whether it's in form of a bottle or a bag or anything else, originated from plastic pellets that were processed into a shape through processes like injection molding or extrusion. They are simply the global standard raw material for the production of almost all plastic parts and products. Even every 3D printing filament is made from plastic pellets. Their small size of only 3 to 5 millimeters is what makes them so different from filament, and the reason why these plastic pellets are so popular in the plastic industry is, for example, the efficient storage. Unlike filament spools, you can put pellets very densely in almost anything. A bag, a container, even an empty shampoo bottle. Since they also can be packed very densely, they take less volume, which means also overall lower shipping costs. But most importantly, they are a lot easier to produce than filament and are as well produced in enormous bigger quantities, which explains partially why they are so cheap. But anyway, in the end, when it comes to the cost of 3D printing, pellets do have a significant advantage over filament, which is why the first point in our 7 aspect comparison here goes to pellet 3D printing. But do pellets also offer the same print quality and part strength as filament does? All savings you could make through pellets would be useless if your 3D prints look like a disaster. Before we can get into that, you have to understand first that the pellet printhead, also known as the hot end, works completely different than your conventional filament printhead. Look, this is a filament extruder, so let me explain how it works in real quick. And let's start with the filament. So you have a piece of filament, and often with a 3D printer there is an entry for the filament. Usually it comes with a PTFE tube. The filament gets inserted and is clamped in place with gears, and those are connected to a stepper motor, which allows us to push filament forward or backward. And all this filament goes along this whole tube and enters the actual extruder, or called hot end. And there awaits this filament a hot or a heating block, which is connected to a heating element and a temperature sensor that allows us to control the temperature of this printhead very precisely. And when the filament is pushed downwards, it enters this heated part, starts to melt, and comes out of this brass nozzle here and gets extruded. And when we mount this to a 3D printer and we can control the movements, we can 3D print with that. With pellet extruders, things work a little different. So let me explain everything with a live example of a pellet extruder that I made myself. Here you see the essential components of a pellet extruder. Very familiar to the hot end is the heating block, which has quite similar features like a hole for the heating cartridge and the temperature sensor. But what really makes the difference are these two parts. On one hand, we have something that is called an extrusion barrel, and on the other hand, something that is called an extrusion screw. They go into each other like this, and then the heating block just gets screwed onto the barrel like this. When I put now a piece of plastic pellet that I have right here inside the barrel, And if I would miss it like this, and the screw gets basically turned leftwards, then the screw automatically is going to push the piece of plastic downwards into the heated zone, where it then starts to melt, and through the other side, where we can screw in any standard 3D printer nozzle, like this one, which is a 0.4mm nozzle, molten plastic is going to come out of the other side. And since the screw we have here is connected to a stepper motor, we can control the flow. And when we mount all of this to a 3D printer with the help of some 3D printed parts, we are gonna be able to 3D print with plastic pellets, which we also gonna do in a second. But what I really can't get out of my head and mind is a very interesting what if question. Look, if we can put small sized objects in our extruder and 3D print with them, wouldn't it be possible to take, for instance, some chocolate, chop it down into smaller pieces and then 3D print with them? Would that be possible? I mean, just imagine you could create your own favorite chocolate, sweets, and ice cream bars by, for example, 3D printing a donut shape, and before the 3D printer closes the top layer, you make it pause the print, and in the meantime, you fill the print with things like grinded nuts, caramel, ice cream, vanilla pudding, or whatever basically comes into your mind. And then you just press continue, and the top gets closed. How would that taste like with all these infill structures and so on? And you know, the fact that you can do all this at home and you are not in a science fiction movie is just unbelievable. I've also seen people who 3D print with sugar, and I bet it's also possible to 3D print with ceramics, cheese, candle wax, and all sorts of materials if you figure out how to do it. And because of this gigantic freedom of choice you have with Pellet 3D printing, the second point in this battle between Filament and Pellet also goes to Pellet 3D printing. However, in the next round, which is about the print quality between Pellet and Filament 3D prints, Pellet 3D printing might get into some really serious trouble since it is not known to produce the best print quality. Some of the known reasons for this are, according to many articles, for example, inconsistency of pellets and the complex melting and extrusion behavior. But what I did not tell you is that my special extruder I showed you earlier is one I've been working on for more than a year now, which means many prior problems that appeared over the course of time have already been solved up to a point where the print quality comes somewhat close to the one of Filament. But instead of talking, I will print now two benches, one with pellets and one with Filament, and then we are going to compare to see whether pellets have any chance against perfect print quality of Filament. Let's go! So this is the 3D printer we are printing on with pellets. Actually, this is a Filament 3D printer called the Creality Ender 3 V2. It costs somewhat around $200, but I just unmounted the Filament printhead that you see right here and just mounted my pellet extruder to it. And instead of having like regular filament spools that it consumes, it now consumes these sort of pellets, or basically everything in granulate form. And instead of having a filament spool, you have something like this. I call it a pellet tank, where it just stores all your pellets and, if needed, just conveys them through this conveyor hose into the extruder hopper. And I'm going to show you this right now, where I just insert some pellets. And then they're going to get conveyed right in here through this conveyor hose. And as you can see, they're going to pile up. But this is how it works. And the rest, all the printing process is basically the same, where you just choose your printing file, in our case, a Benchy, and you just press start. And then it makes the auto home and levels the bed if you have a leveling sensor, but the rest is basically the same. In the meantime, while everything is printing, let me explain to you why exactly pellet extruders have a much harder time producing consistent flow rates than filament extruders. Take a look at this image. What you see here is supposed to be a visual representation of the actual flow of a filament extruder. Even though you might have set a flow rate of 100% on your 3D printer, you're still gonna have tolerances within your layer line thickness of about 0.5%, which is basically so small that it is not noticeable. Things, however, look different when you 3D print with standard pellets. What are standard pellets? simply those that are typically available everywhere and usually are used in injection molding or extrusion and so on. On average, they have a size somewhere between 3 to 5 millimeters, and compared to the machines they are used in, these pellets are very tiny. However, when we compare them to our pellet extruder, then they are actually gigantic. And when you try to fit them inside the extruder barrel I showed you earlier, they will stack up very unevenly, which in the end results in an uneven flow rate that fluctuates around 15%. 15% sounds very dramatic, but in reality the difference is hardly visible. Only when you get very close, and I'm gonna show you now what I mean by that. So these are the two benches we 3D printed. Both are made out of PLA and printed with a 0.4mm nozzle. And now we're gonna take a closer look, and I want you to tell me which of them is the Pellet 3D printed one. So take a closer look of them. And the thing is, when the light shines onto the layers, it is quite easy to spot the difference. But if I wouldn't show you them so close, it would be almost impossible to guess which is filament and which is pellet. The reason why they also have a different color is because the one with filament, which is by the way this one, and this is the one with pellets, is because the filament has a more white color and the pellets do have a more cream-like color. That's why they have such a color difference. But you see, it is actually not that bad, those pellets. And one important thing to note is that if I would tweak the slicer settings or the printer settings for the Pellet 3D print, then I think I could get a much more better print quality out of this than the current result I have right here. And here are also some other images of objects that I have 3D printed with pellets, so just that you can get a feeling of how they look like in general. Two of those vases have also been spray painted, and I noticed that the additional layer of paint does a really good job at hiding imperfections. And while the print quality of all these 3D prints is for pellet 3D printing standards very good, Filament still offers a better print quality, which is why the third point goes to Filament. Now let's talk about the part strength. Is there a difference? Unfortunately, I do not have any measurement machines to conduct scientific measurements, but what I can tell you from my own experience is that filament prints are a little bit stronger than pellet ones. And I think that the reason for this is due to the more consistent flow rate of filament, which bonds the layer lines better together across the whole print. Of course, on pellet prints you could just increase the wall thickness to compensate for that, since the material costs less anyways. However, this would then also increase the print time, so I guess it's in the end a compromise question. But all things being equal, filament parts are a bit stronger, which makes filament the winner when it comes to the part strength. The next topic is very important: recyclability. So let's talk about recycling 3D printing waste into new filament at home. The usual process of doing that is by shredding your waste first and then processing it into new filament. This unfortunately sounds easier than it actually is, and often also requires an upfront investment of up to $1,000 to $5,000 for a shredder and a filament extrusion machine. And while the feeling of turning your own plastic waste into whatever physical object you want is more than just amazing, the upfront cost for this is, in my opinion, still way too high for the majority of people. Which brings us also to the question, is that also the case with turning plastic waste into pellets, so that we can 3D print with them directly through our pellet extruder? Well, since I'm involved into pellet 3D printing for a very long time now, and since I've successfully recycled 3D printing and even household waste like bottles through various ways, I can say the following. Turning plastic waste into pellets can be much easier and cheaper than turning it into filament, and here's why. With filament, there are much more steps involved producing it. After shredding your plastic waste, it needs to be extruded, then cooled, then measured, then winded on a spool, and so on. Every step adds cost. With pellets, you just need to somehow transform your plastic waste again into pellets, and most often this is done by simply shredding them, and that's basically it. However, buying a good shredder that produces pellets small enough to actually 3D print or produce filament with still usually costs more than $1,000. which is why I have tried many alternative methods to produce pellets out of plastic waste, and these other methods do also work to some degree, but they are not what I, for my standards, would call optimal. For this reason, I came up with my own approach that is much simpler and cheaper than shredding machines. It allows you to recycle your 3D printing and even household plastic waste for less than $100, and I'm going to make a video about it in the future, which is why you should subscribe if you haven't already. But even without my new approach, pellet 3D printing definitely wins over filament when it comes to the recyclability, because the process of making pellets is so much simpler and therefore costs less. Next topic is also quite interesting. It's about the material choice between filament and pellets. For instance, if you want to print a part that is strong and can withstand high temperatures, then people often use nylon carbon fiber for that. But with pellets, things go much more beyond just your typical nylon carbon fiber. There are different variations and modifications where you can choose between 10, 20, 30, even 50% fiber content, with data sheets that tell you the exact tensile strength and all other material properties. Like this one, about the material PPA GF50. That is basically nylon on steroids, but with 50% glass instead of carbon fibers. It outcompetes regular nylon by far in most areas, withstands higher temperatures, and costs on average only $5 per kilogram when bought in pellets. Because it is a mass-produced plastic that is used globally in the automotive industry to replace metal parts. And just for proof, I have a 25 kilogram bag of that plastic, which I bought on eBay for $120. I do also have another bag of 25 kilograms of PPA, but with 35% glass fibers instead of 50%, which I also bought on eBay from this seller. And as you can see, it costs even less. 85 euros for the bag plus 16.5 euros for shipping. This results in a total of $109 and 30 cents. And you know what's funny? When you want it as a filament, you need to pay on average $240 for a single spool. And if you don't believe me, then you can just search in your browser PPA filament. But I do not recommend you to do that, because first, what you're gonna see is gonna shock you, and second, you're gonna start to believe it's just a scam, or filament is just a scam. But let's forget about that and continue with our topic. There are also many other plastics that simply do not exist as filament, but do in form of pellets. For example, like this extremely elastic TPE, which for example could be used to 3D print a real rubber band for a slingshot. And that is just a fraction of the choice you actually have with pellet 3D printing, which makes it, in my opinion, also the winner when it comes to the material choice. The last aspect is about customization. When you have, let's say, two spools of PLA filament, one in red, one in blue, then you can't just mix them together to create, for example, real gradient color prints. For that, you have to buy an extra spool of gradients blue-red filament, even when you just need 20 grams of it and not a whole spool. And what's gonna happen over time is that you end up with a bunch of filament spools you barely use, like in my background here. When you 3D print with pellets, you can do what I have done. I simply bought a 20 kilogram bag of white PLA pellets for $4.50 as the base price per kilogram, plus $50 shipping cost, which results in a total of $6.25 per kilogram. Then I bought a set of 30 color pigments on Amazon for $10, which you can then mix with your palettes to get colored prints. And through this method, you can suddenly 3D print with any color you like: gold, red, silver, shiny black, and so on. And you can also stack those colored palettes on top of each other to get real gradient prints and all sorts of colors and types of gradients. All of that with a fraction of the filament cost. If you only need 20 grams of yellow PLA, you just take 20 grams of PLA pellets, mix them with powder, and then you get 20 grams of yellow PLA. If you do that with transparent pellets, you can end up with yellow half-transparent prints. Theoretically, you could also add glow-in-the-dark powder to your pellets to create 3D prints that actually glow in the dark. And on the other hand, if you want to 3D print with, let's say, white chocolate, then you could melt it first and then add red food coloring to it and strawberry flavor, which then results in red 3D printed chocolate with strawberry flavor. You see, there are basically unlimited possibilities with pellet 3D printing that you simply do not have with filament, since whenever you want a different color or you run out of filament, you are always forced to buy a new spool of that. It is very similar to the ink cartridge system from normal 2D printers that print ink on paper, just with the difference that you theoretically could reuse your filament for recycling. And maybe I've done a better job in research, but I don't know any desktop 3D printer manufacturer that also offers a recycling solution for the 3D printing waste that their machines produce. And I find that sad, really. But anyways, we were talking about customizability. And this is a topic we could talk about for a very long time, but I think it's clear that the point for this aspect also goes to pellet 3D printing. And according to the points we gave for each category, pellet 3D printing might be the winner, but in the end, is it really better than filament printing? Both have advantages and disadvantages, which brings me to the conclusion that the only satisfying answer to the question which of them is actually better is it depends. On what exactly? Well, if you want to have the best possible strength and print quality on all your parts and you don't mind paying a higher price for that, then filament is clearly the better choice. On the other hand, if you are still satisfied with a maybe not perfect, but still overall good print quality and part strength, then you should consider 3D printing with pellets, since you will pay significantly less for the same printing materials like PLA, ABS and so on. Plus, you can 3D print your own custom chocolate, sweets, candy or whatever comes into your mind, and in addition to that you will also have a much easier time recycling your, for instance, failed prints back into pellets, because the process of doing that involves less steps compared to filament. But let me know down in the comments what your opinion is about all of this. If you're, by the way, interested in chocolate 3D printing, then you should know that in one of my next videos I will actually try to 3D print my own chocolate creations and will show you how you can do this step by step too. If you don't want to miss it and the other videos about pellet 3D printing and plastic recycling that will appear in the next couple of weeks and months on this channel, then I suggest you to subscribe. If you have any questions regarding this video or my extruder I showed you earlier, then do not hesitate to ask in the comment section. Otherwise, have a nice day and until next time.